Hello, I'm Yarkın Müftüoğlu, a student of computer science at Bilkent University. In this video, I will present the experiment I conducted as part of the PHYS102 project. In this experiment, a charge object is observed to be in equilibrium at a specific angle under the influence of a horizontal electric force and a vertical gravitational force applied to it by an electric field. The experiment will be repeated with 3 different voltage values, keeping other values constant, and data will be collected. With this data, the electric charge of the charge object will be calculated experimentally. The calculated value will be compared with the theoretical value to calculate the percent error. As you can see, our experiment materials include 1 voltage supply, a precision scale, a ruler, scissors, tape, a stabilizing setup, an electric field setup, a pendulum from which the object is suspended, a protector, 5 9-volt batteries to reach the 45-volt level that the voltage supply cannot reach, and FF cables. Although the scale used in the experiment has a precision of 0.01 grams, it cannot measure the mass of an object as small as 0.001 grams. For this reason, the mass of a styrofoam piece with a length of 0.5 millimeters by 7.5 millimeters was measured as 0.15 grams. Then 1/15 of this length was taken. The object was charged to its maximum level through static electrification by rubbing it against hair for a long time, and then was hung on the pendulum. Initially, the power supply was set to 20 volts. In this trial, the angle was measured as 2.1 degrees. Afterward, keeping everything else constant, the measurement was repeated for 30 volts and 45 volts, yielding values of 3.20 degrees and 4.70 degrees respectively. The voltages are the values coming from the power supply, and the batteries, the angles, were measured with the protector during the experiments. From these angles, the tangent values were obtained. The electric field values were obtained by dividing the voltage by 0.04 meters. Our focus will be tangent values we obtained. The tangent value is equal to the ratio of the electric force to the gravitational force, which is product of charge and electric field, or the product of mass and gravitational acceleration. Since we know all the other values, we will be able to calculate the charge experimentally using the relationship. The necessary calculations lead to these charge Q values. Theoretical amount of charge the object is expected to have is 7.0 times 10 to the power of negative 9 coulombs. When we create a graph by plotting the tangent values obtained from the experiments against the voltage, the slope of the best fit line is found to be 0.00180. And this general value gives us the relationship between tangent of theta and voltage. When we perform the calculation using this slope, the charge held by the object is calculated to be 7.20 times 10 to the power of negative 9 coulombs. The overall percent error is calculated approximately 2.86%. The significant deviation is considered reasonable, reflected the inherent challenge of this sensitive experiment. The primary source of error is attributed to uncertainty in the angle measurement. Since the equilibrium angles were very small, even a minor deviation of 0.1 degrees in measuring the angle resulted in a disproportionately large error in the tangent value and consequently the calculated charge.